let us suppose if we have a situation over here that the garden of this particular house is in the shape of a triangle. So as you can see over here, the garden is actually into the formation of a triangle, and its sides are actually given to us as nothing but 24 meters. Further we have 32 meters, and further we have 40 meters. So as you can see, all the sides are of 24 meter, 32 meter, 40 meter, which are actually different from each other. So it means that this is nothing but a triangle, which is called as a scalene triangle, So can you able to find out the area of this particular triangle? So obviously, to find out the area of this particular case of a triangle, which is nothing but a scalene triangle, we just have to use a special kind of a formula which will help us to find the area of this triangle in a very easy manner. So this is all about our chapter, which is nothing but called as the Heron's formula. Heron's formula will help us to find the area of such a type of a triangle in which all the sides are not equal to each other. So let us suppose if I'm talking about the Heron's formula. So Heron's formula is actually developed by Heron's. He's a great mathematician, and just because of his name as a Heron, so this formula is called as the Heron's formula. So this is nothing but a formula of the type in which area of the triangle is nothing but is equal to square root of s into s minus a into s minus b into s minus of c, where a, b, c are nothing but the sides of the triangle, and thus it is nothing but called as the Heron's formula. So always remember, whenever we just wanted to find out the area of the triangle such that all the sides are not equal to each other, then we can use this type of a formula to find out the area of the triangle in a very easy manner, which is nothing but is equal to square root of s minus a, s minus b into s minus c, and this is nothing but called as the Heron's formula. Now let us suppose if I'm talking about this formula again. So area of the triangle is nothing but is equal to square root of, so let us suppose if I am writing the triangle over here, so let us suppose this is my triangle. So area of the triangle is nothing but is equal to square root of s minus a, s minus b, s minus c, where a, b, c are the sides of a triangle. A, b, c are the sides of the triangle. So let us suppose if I am drawing a triangle over here, so this is nothing but my triangle, and let us suppose this is A, this is B, this is C, and if I'm taking the A side, which is just in front of the A vertex, and if I'm taking it as a B side, which is just opposite to the B vertex, further I'm taking this as nothing but the C, which is just opposite to the C vertex or the C angle. So let us suppose if I'm taking such a type of a triangle in which we have the different sides as A, B and C. So for such a type of a triangle, the area of the triangle is nothing but square root of s minus a, s minus b, s minus c, and remember s is nothing but called as the semi-perimeter. It is called as the semi-perimeter, and the value of s is nothing but is equal to a plus b plus c divided by 2. As you can see over here, the formula for finding out the value of s is a plus b plus c divided by 2. So always remember, the Heron's formula for a triangle having the sides as a, b and c is nothing but square root of s minus a, s minus b into s minus c, where s is called as the semi-perimeter, which is a plus b plus c by 2, and a, b, c are the sides which are opposite to the angle a, to the b and to the c. So this is all about the Heron's formula. Now let us suppose we have again that triangular garden. As you can see, this is nothing but my triangular garden, and I am just making a triangle over here. So let us suppose this is nothing but my triangular garden, and its sides are actually given to us as 24 meter, 32 meter and 40 meter. Now let us suppose if I just wanted to find out the area of this particular triangle using the Heron's formula. So how we can calculate it? Let's just find out. As let us suppose if I'm taking this as nothing but vertex A, let us suppose if I'm taking it as nothing but B, if I'm taking as nothing but C, so this would be my small a, this would be my small b, this would be my small c. So let us suppose first of all find out the semi-perimeter of the Heron's formula. So the semi-perimeter was a plus b plus c by 2. Let's just substitute all the values over here. So this would be nothing but a is 40, b is 32 and c is nothing but 24. So this is 40 plus 32 plus 24 divided by 2. So s would be nothing but is equal to, this would be 72 plus 24 divided by 2, and this is nothing but 7 and 2 is 9, and this is 6 divided by 2, and further it is 2 into 4 is 8, and we have 1, so this is nothing but 8. So hence the semi-perimeter is nothing but 48 meters. Semi-perimeter is coming out to be is equal to 48 meter, and we just wanted to find out the area using the Heron's formula. So let us suppose if I'm starting with finding out the area of the triangle ABC, so this would be nothing but is equal to square root of S minus of A, S minus of B, S minus of C. So let's just plug in all the values over here. So S is nothing but 48. As you can see, we have calculated the value of S as 48. So this would be nothing but 48 minus of A. The value of A we have taken is as 40. Further we have 48 minus of B. The value of B is nothing but 32, and further we have 48 minus C. C is nothing but 24, all under the 1 square root. Now let us suppose we are taking the value again. So this would be nothing but 48. Further we have 48 minus 40, which is 8. Further we have the values as nothing but 16, because 16 plus 32 is again 48. Into further we have the value as 24. We have 24. So this is nothing but square root of 48, 8, 16 and 24. Now let us suppose if I'll factorize all these elements, if we'll calculate the factors of 48, if we have calculated the factors of the 8, or if we are using the prime factorization of all these factors, then at the end, if after finding the prime factorization of all these particular numbers, we have at the end will get the value as nothing but is equal to 384. We will get the value as nothing but is equal to 384 at the end after taking a square root of all these elements. So this would be nothing but is equal to that area of the triangle ABC is nothing but 384 meters square, and this would be nothing but the answer for this particular area of the triangle ABC, whose sides are 24 meter, 32 meter and 40 meter using the Heron's formula. Now it is not necessary that a triangle should be only a scalene one, for which we have to use the Heron's formula. We can also use the Heron's formula for the isosceles triangle, for a right angle triangle, and further so goes on. So we can also verify using the Heron's formula that whether the areas of the previous type of the triangles, that is equilateral triangle that we have calculated, the area of the equilateral triangle, isosceles triangle, we can also use the Heron's formula in that case of triangle as well. So always remember, Heron's formula can be used where all the sides are given to us as this and this, all the three sides are given to us, whether they are equal to each other or they are not equal to each other, it doesn't matter. You can use the Heron's formula whenever the three sides of a triangle are given. So this is all about finding out the area of this triangular garden using the Heron's formula.